Hello guys, welcome back to a new video. In today's video we are here to discuss a very important topic of chemistry. Basically we are starting a new series. We are done with the gases series on our channel. If you haven't checked out gas series, do check that out. And in today's video we are initiating the liquid series. In this we will look into all the concepts related to the liquid, and this is the part 1 or the overview video of the liquid, like what liquids are and what are the KMT or the kinetic molecular theory points about the liquid. So let's get into it. So liquids introduction and KMT. Today's our topic is this, right? Liquids introduction and KMT. KMT is a kinetic molecular theory, while liquid is one of the state of matter. Liquid, we have all known about this, like there are 3 states of matter: solid, liquid and gas. Liquid is one of them, and we are studying liquid. Now we have got some beautiful pictures over here for you guys, and you will see that these are liquids. Like here you will see a beautiful picture. These both pictures I just this shows how liquids are, like they have taken the shape of the containers and all that. While here we are having another picture which is showing you more concepts. Of course we will be getting into it. So let us start. First of all, a liquid, if we talk about the liquids, so liquid are having a liquid is a state of matter in which the molecules are having weak intermolecular forces, weak or short intermolecular forces, sorry. So in solid you're gonna see it is having strong intermolecular forces. In liquids we are having weak molecular forces, and in gases we are having almost no intermolecular forces or attraction between the atoms. You can see in simple wordings. So there it is how it works. Like if you see simply over here, if we have got a solid, the atoms are tightly packed together, so it has formed a cube. It has got a proper shape like this one, right? It has got a proper shape. If you talk about a liquid, you're gonna see that this is all having this liquid is joined all together, but there is no any proper shape. This shows that molecules are closer, but they are not having any specific or tight geometry. While in gases you're gonna see some molecules are here, some are there, they are not having any sort of interaction or connection. So this means that the molecular arrangement is far apart, and there is the miss of intermolecular forces or the attraction between the atoms of a gas. This is how the liquid differentiates. Uh, uh, Now let's move on to the next point. Uh, Liquids are, the molecules of liquids slide over each other. Like this one slides over this surface, and this one slides over this surface, and this one slides over this surface, and this makes liquid to be said to be a fluid. Like the fluid is something that flows, and hence liquid molecules slide over each other, and they are used as a fluid. Like water is one of the good example. Water is kind of a liquid. Liquids are having great importance. Like water is the biggest example of a liquid. How important liquids are, this shows. uh, they are uncountable. Basically, if we talk about solid, liquid and gases, all of these are having their own importance and playing the role in nature. In liquid we have got the great example of water, and we are drinking liquid water. In our body we have got 70% of water. uh, in the earth we have got uh, water covered in a large area. So this is how liquid works. And if we talk about KMT, basically what KMT is, KMT is kinetic molecular theory. So the kinetic molecular theory is a theory which explains the behavior of the states of matter. Like in KMT of gases we have discussed in our previous video, like you can check that out. We have mentioned about the behavior of gases or the properties or the characteristics of gases, while in the same case we are having KMT of liquid as well as KMT of gas. So the KMT of liquid states that the liquid molecules are close together, but are having small spaces. Just look into this diagram, you will get your all concepts clear. This diagram, just this diagram, this number 1 point is very clear in this. Like KMT says that liquid molecules are close together. Yes, they are, but they are having small, uh, what we say, small intermolecular spaces. Yes, they are having spaces. Like here we have got a space, here we have got a space. So just simply how it works. If you talk about other gases, and there is no space in this. There are very large spaces, very large spaces in these. So of course there is a difference. Uh, Now the liquids molecules are having uh, uh, no appropriate arrangement of the atoms. Like here you see there is a proper geometry. Like here is one line, then here we have second line, here we have got third line. But here you're gonna see that here is like sections are like this divided. There is no proper geometry. If you talk about gases, these are even having worse geometry than the liquids. So I do hope that you are understanding with this diagram. Like it's very clear. So the best geometries of solid and the weaker geometries of liquid, and the worst or the most weakest geometries of gases. And if you talk about the next point, so liquid molecules are always in motion. A solid, it is if I going to tell you guys, like uh, everything in the nature is having its motion. It whether it's solids are having very minor motion, like we cannot notice that, while liquids are also having motion among their atoms, while gases are having the most motion. Like gases are having the most motion here, hence we see that they got diffused from one place to another. Liquids are having minor motion because we just touch them a bit and they just flow apart, because there is of course kind of motion between the particles. And the liquid motion is also called sometimes as Brownian motion, while the solids are having very minor motion. They are acting as a rigid surface. uh, Now let's move forward. I think that we are kind of done with uh, all of it. Like I would include that liquid motion is restricted. Liquid motion is restricted. Like molecules can move, but there is a limit. While in gases, it cannot. It is not restricted. Like gas molecules can go up in the sky and then come back, and just temperature high and low. This process continues throughout the sky and the land. But liquid molecules are restricted. You cannot say that you flow the water and the water goes from 100 kilometer apart from the place you've thrown. But gases can flow, of course. So this is how where the difference comes. I do hope that you've got the concept. uh, like you see that liquids are not having a proper shape, but they're having proper volume. So you're gonna see that we have got different shapes. This is one shape, this is second shape. So liquid has taken the shape, but it is having proper volume. So like if you talk about length into breadth, so if you find that here it is 100 ml, 100 ml in this flask, so here would be 100 ml in this flask as well. This cannot happen that in this flask the liquid would come on this surface like 50 ml. This is not possible. The volume is constant, and the shape is changeable, right? I do hope that you've got the concept. Meet you guys in the next video. Till that, goodbye.